This is lesson 9.6, which is the quadratic formula. Our essential question is, when should you use the quadratic formula to solve equations? So in our last lesson, we looked at how we can solve a quadratic by factoring. Well, we know that not all quadratic functions are factorable, and so the quadratic formula is a formula we can use for any quadratic. So it's especially useful if we can't factor, but it can actually be used to solve any quadratic, even those that we are able to factor. So if we have the quadratic equation in the form ax squared plus bx plus c, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So our first example, how can you use the quadratic formula to find the solutions of x squared minus 7 equals 4x? So first of all, we need to put this in standard form, and we need to set our quadratic equation equal to 0. So to do that, I'm going to subtract 4x from both sides, which is going to give me x squared minus 4x minus 7 equals 0. Then the next thing I like to do is I like to make a list of what my a, b, c values are. So I have no number with x squared, which means a is 1. My b value is negative 4, and my c value is negative 7. So now we're going to fill in all those values into our quadratic formula. So it starts out with negative b. So anytime I'm substituting a value in a, b, or c into the quadratic formula, I'm putting parentheses around it, so that way I make sure that I'm not distributing incorrectly. So I'm going to say negative b, so b is negative 4. So I'm writing negative 4 plus or minus the square root of b squared, so be negative 4 squared, minus 4 times a times c, and then that whole thing, not just the square root part, but the whole thing is over 2 times a. So then it's important, you can't type this into your calculator all in one step. So you need to do this in phases here. So the first thing I know is I know that negative 4 is just positive 4. So I'm going to write positive 4. Then I'm going to take my calculator and I'm going to type in everything I see underneath the square root sign right there. So if I do that, I get 44. Notice I didn't type the square root sign in, I just typed parentheses negative 4 squared minus 4 times 1 times negative 7, and I got 44. Over 2 times 1 is just 2. So at this point, we need to break it up into two separate equations here. So we have x equals 4 plus the square root of 44 over 2, and we have 4 minus the square root of 44 over 2. Now when you're typing this part into your calculator, make sure either you put parentheses around the whole numerator, the 4 minus square root of 44 or this 4 plus square root of 44, or you hit enter and then divide by 2. So you have to be careful to make sure you're doing the addition or subtraction first before the division. So if you do that, we get approximately 5.32. Oops, I'm running out of space here. So I'm going to write it over here. So x is approximately 5.32 from our top equation, and x is approximately negative 1.32. So that means that if I were to graph this in Desmos, you would see that those x-intercept solutions are approximately at those decimal values. But you'll notice they're not whole numbers like they have been when we're factoring. Okay, here's our next example. This is a real-life situation. It says the function shown represents the height of a frog, x seconds after it jumps off a rock. Actually, it should be t seconds. How many seconds is the frog in the air before it lands on the ground? So I can see here that a is negative 16, b is 10, and c is 0.75. Oops. C is that right there. Okay, so if I use my quadratic formula, so x equals negative 10 plus or minus the square root of 10 squared minus 4 times negative 16 times 0.75 all over 2 times negative 16. So if we simplify this, we get negative 10 plus or minus the square root. If I type that whole part that's underneath the square root into my calculator, I'm going to get 148 over negative 32. So then we can put this into two equations. So x equals negative 10 plus the square root of 148 over negative 32. And we get negative 0.068 and negative 10 minus the square root of 148 over negative 32, and we get approximately 0.693. So if we're talking about time, we can't really have negative time, so that means that that value is out. And we notice it would be negative because if we continued the parabola down, it would cross at a negative value. But when we're talking about a frog's not going back in time. So that means that that solution right there is the solution we want, which is our positive value, which would be 0.69, or we could say about 0.7 seconds. So our last example is understanding the discriminant. So if we look at our quadratic formula, the discriminant is the part that is underneath the square root sign. So that right there is our discriminant. Oops. So b squared minus 4ac is our discriminant. So the reason that it can tell us extra information is because we know that we've talked about how if we take the square root of a negative number, we can't do that. It's going to give us a non-real number. So that tells us that we can revisit our three situations of parabolas. We can have a parabola that crosses the x-axis and it has two solutions. We can have a parabola that sits on the x-axis and has one solution, or we can have one that doesn't cross the x-axis and has no solutions. So our discriminant is going to tell us that. So if b squared minus 4ac, so the part underneath the square root sign, like in our previous two examples that we've looked at, is greater than 0, then that means we're going to have two solutions. So that would be that top picture. If b squared minus 4ac is equal to 0, then we know that whatever our negative b value is, we're going to add and subtract the same number, or add and subtract 0, which would keep it the same number. So that would mean that we have one solution, which would be that situation. And then finally, if b squared minus 4ac is less than 0, that's where we have no solution, which would be that situation right there. So we can look at the discriminant, so we don't have to do the whole quadratic formula. We can just take the discriminant, plug in the numbers to predict how many solutions for our quadratic equation we would have. Okay, so